Hey, just a quick one. So I have finally gotten my large scene renderer sort of working a little bit better. Here's where I was before I went and modified things. This is from a series I did a long time ago, video I did a long time ago. We have 10,000 models, all sort of randomly distributed around the scene. And currently, that's rendering at, almost 100 frames per second. As always, it is limited by OBS. But the system is not stable, so as we look around, we see that objects are like randomly popping in and out of view. That's not good. I mean, obviously the frame rate's going to be better if we're not rendering everything. What I did is I took the day and I just ran through my whole system and I implemented the screen space AABB technique that I showed in one of my previous videos. And here's what that looks like. Same number of objects, same everything. So here we've got a few things. First up, we've got a slightly improved frame rate. But of course, as we get down to these lower frame rates, it becomes very important because the time difference between frame rates is quite large. But most importantly, we have no glitches. We have no models popping in and out. And also I applied MIP mapping so the textures look nicer. Anyway, the code for this is available currently on my GitHub repo, OpenGL for beginners. I am planning to make tutorials about this topic, but it just takes a lot of time, so I had to sit down and code the thing up to begin with. Now, all of this culling is happening on the GPU in a compute shader, as well as the updates. And I was a little bit lazy, so I'm actually updating the indirect draw calls with a second compute shader. Compute shaders all the way. Now, something which has got me a little bit rattled is the fact that, before I do that, I should mention, big shout out, MVP would have to be Nvidia Insight graphics. It's so good. Here's how easy it is to use. I just start an activity. I point it just the same way as I would with RenderDoc to my program. And then I just go frame debugger, launch it. It launches everything up. And then I just hit F11 to capture a frame. And then here I've got access to everything in the frame. And the stuff that for me is a real game changer is I can view the contents of my buffers. So I can go look in at one of my buffers. For instance, this buffer here is my atomic counter buffer. That is describing all of my draw calls. And I need to configure this. So I'll just change the format and say, hey, we're going to interpret these as uints. And there we have it. So I can see, for instance, my index counts of all of my models, my instance counts, so how many of these things are visible and are going to get drawn, as well as some other info like the first instance, base vertex, and then base instance. In this case, the base instance is being used to get an offset into the model transform buffer. But anyway, we can do this for anything, right? And it's just super, super useful because I don't know about you, but I am not psychic. I have no idea most of the time. I just spent 3 hours on a bug that was, let me bring this up. I created my indirect buffer to store my draw calls, and then I bound it to the shader storage instead of the atomic counter. I spent probably more, but it felt like a long time on that one error. Oh my goodness. But anyway, that was not what I was going to say. I'm just rambling. We're having fun. The thing that got me rattled was that if I do the exact same thing, but generating those draw calls on the CPU and not the GPU, okay, it's struggling now. It's struggling, but when OBS was off, it was performing better. Anyway, the point I'm getting at is this has sort of got me thinking, like, what if we get the CPU and the GPU working together? Is there some way, because right now, okay, we're we're view culling basically. We're looking through the scene, we're testing every single object, and that's a one-by-one thing. It's embarrassingly parallel, so a GPU handles it just fine. But if we had some sort of acceleration structure like a bounding volume hierarchy, we could cut out like half of the scene in one go or something. That's a boss move. That's a game changer. So if there's some way that I could do a coarse test with the CPU, like a pre-pass, and like paint out like a whole bunch of IDs and say these are the set of things which it would not be worth it for the CPU to test it further, but they're potentially visible, and then throw that over to the GPU, then I could reduce the workload on the GPU, because the GPU, it does a good job, but it will struggle the same way that any other computer would. But you see what I'm saying? Geometric tests are pretty good for single-threaded performance because they're like logarithmic. You can cut out so much. But then if that reduces an amount of parallel work, which has benefits as well. So I'm literally just talking to myself, but I just wanted to make this quick little update. And yeah, link down below. All this code is available. Some of it I've written up articles on, readmes. All of it I'm going to be writing tutorials on. But anyway, that is it for now, and I will see you again soon. Bye. Hi, so I just wanted to take a second to say thank you to all of my channel supporters. If you would like to support the channel, it's $2.50 a month. That's all I ask, but it's not expected. If you are not able or willing to support the channel financially, the best thing you can do is the usual: like, comment, subscribe. Let me know what you'd like to see. Let me know what you're enjoying, because I am trying to make the best educational content that I can under the constraints. So with that out of the way, really big thank you to Antonin Karet, Dankil Foles, Declan, Endelon Studios, Isaiah Meyer, Mathieu Derick, Moim, and Shreya. Thank you so much, my dudes. I really do appreciate it. It's fuel for the fire. Keep me going, keep me motivated. But yeah, have a great one, and I'll see you again soon. Bye.